usually your two theorems on paper 3 that will show up is the Rolle's theorem and mean value theorem. They're pretty easy questions. So, for example, if you plot the points 2, 2, so 2, 2, and 7, 2 on a graph, right? Draw 3 graphs of a differentiable function. Remember, a differentiable function just means a function, right? So, I mean, you could have a straight line like this, and I'm just drawing a dot because I might have done 3 different functions. Or let's say you have like, oh, there it is, right? You have something like that, right? Or let's say you've got something that goes like, I don't know. Okay, yeah. Like this? Sure, right? Or there are 2 points on that line. Can you draw a picture where there's not a slope that is not 0? Right? Can you draw any type? No. Like, between 2 points, there has to be a slope of 0 somewhere. Because if it was like a not a straight line, then you wouldn't be able to hit both points that are on the same horizontal slope, right? So what Rolle's theorem says is between any 2 points, there is a slope of 0 somewhere. That's it. That's all it says. So, and Mr. Rolls was, yeah, his last name was Royce. All right, here we go. What did I do? Went down in history. Oh boy. Okay, so some reason. Sorry for that technical difficulty. Yay! All right. Anyway, Rolle's theorem, right? If you have 2 points with the same x value, there is a slope of 0 somewhere. Same y value. So maybe do that for me. Thank you. See? I big exam. No big deal. Alright. Show the Rolle's theorem holds between the intercepts of x2 and 5, 6. Really quick. Factor that for me. So at 2 and 3, right? So we know that there is some type of graph between 2 and 3, right? Where the intercepts are x equals 2 and 3. Is the curve continuous? Yes. Is it differentiable? Yes. There's no poles. There's no limits, right? In other words, all polynomials are differentiable. Right? All polynomials should be differentiable. So if it's differentiable, differentiate. Here we go. So if prime of x is equal to, do the original equation. What do you do? Dude. Yeah. Yay. Then you set that equal to 0. So 0 is equal to 2x minus 5. Just in time, are ya? Woo! Pick the buffet! That's all good. Yeah. Yeah. X equals 5 over 2. God bless you. Beautiful. Oh boy. So, over here, where the slope is 0, you're at 5 over 2. So the slope is 0. That's it. Remember that the derivative just means slope, right? That f of h minus x formula, da da da. That's just the slope formula. That's why that's not 1 over x. Okay? Alright. Here we go. All you missed, Arya, was that any 2 points that have the same y value? Okay, good. To have the same y value, you can have a slope of 0 somewhere. It's called Rolle's theorem, and it appeared on one of the paper 3s a couple years ago. Yeah? Alright. Good. times. Yeah. For all the values, find the Rolle's theorem holds for the roots of 3x squared minus x to the 4. We're going to calculate it really quick. That's 3x squared minus x to the 4 equals 0. Yeah, and 0. So x is equal to 0 and plus or minus the square root of 3, which means one of your x values, if x was 0, oh, I'm sorry, which means a would be negative root 3 and b positive root 3, or vice versa, whichever. Yeah? If you take the derivative of that, so that equal to 0. 4. Sorry, 4. Yeah. Is that better? Wait. Wait a minute. What did I do? 6x, 4x to the third. Got it. But wait, I took an x out. So would that be x squared, right? Okay, so that's right. Oh, that's it. Okay. So you have zeros at x equals 0 and plus or minus the square root of 2/3. Or is it 3 over 2? Squared. Nope, 3 over 2. Yeah. Oh, that's ugly. Okay. Alright, here we go. Y equals, and if you go 3x squared minus x to the 4th, the graph is going to look something like this. Oh, no faith this time. No faith. You zoom in. You're a man of no faith. Oh. Oh, yeah, that's a good time. There you go. Yeah? So, basically, here's what the picture says. Right? A and B are where x equals 0. So, like right here is negative root 3. And right here is positive root 3. Yeah? And where are the slopes? That's good. Yeah. So here, here, and here. So there's x equals 0, and this must be negative root 3 over 2. Positive. So I have a 0 slope here, here, here. So that's what I'm saying. Good times. Good times. All right. The mean value theorem says that if you take any 2 points, they do not have to be the same y value. In fact, it would be better if they were not the same y value. There is a derivative. The slope is equal to the tangent that is parallel to the slope of those 2 lines that those 2 lines make. That's what the mean value theorem says. This is parallel to the 2 lines. Right? So here's the picture. Oh, let me go to mean value theorem. Sorry. Yeah. There you go. Okay. Yeah. So let's say you have 2 points, right? That means there's a slope that's just parallel to it. Tangent line should have the same slope as the line it goes. Makes sense. It works for Rolle's theorem because the slope of the last one is 0. Right? Same point. What? Yeah. They're not connected, they're parallel. What are you talking about? Oh, that. Oh, sorry, whatever. Here we go. Yeah. Anyway, that point where that slope happens, there's a point C between A and B where the slope is the same as the slope of A and B. That's all. That's all that says. All right. Here we go. Two easiest theorems ever. All right. So you're given f of x is 3 minus 5 over x in the interval 1 to 5. So that satisfies the mean value theorem. Okay. Well, we're at 1. Wait, in the interval 1 to 5. So at 1, the point is like right here-ish somewhere. And then 5 is like right here. So here's the secant line between those 2 points. So the slope must be parallel to that secant line. It's true. Right? Since we don't like fractions when doing derivatives, you can write that as 3 equals 5 to, 3 minus, 5 to the x to the negative 5. Truth? Truth. And if you take the derivative of that, remember what the derivative of a constant is? 0. And so the derivative of negative 5x to negative 1 would be positive 5x to the negative 2. 5 over x squared. Good on you, mates. Yay. So drawing in the mean value theorem means there's some point C, right? That would be parallel to that line. We just have to find that C. So if you use the formula f of C is equal to f of B minus f of A over B minus A, then that turns out to be f of 5 minus f of 1, 5 minus 1. Oh, hello. Sorry, never mind. Yeah? If you plug in 5 into the formula, you would get 2. If you plug in 1 into the formula, you would get negative. This is negative 2. Is it 4? Why am I getting 5? No, that's okay. Here we go. So that would be negative 2. Yeah, you're right. So 2 minus negative 2 over 4. Truth? Okay. So it goes to 1, which means that x squared is equal to, if you plug it, sorry about that, if you plug the 1 into the f prime of x, let me do that down here. Here we go. So C would be 1. So f prime at 1 would be, what's that? Wait a minute. Oh, my bad. Okay, no. So if that was equal to, so your C is 1, right? So if f of, sorry about that. So if C is 1, then 1 would be where 5 over x squared is. Right, that's f of C. Alright, so set that equal to the derivative, and then you'd have x squared is equal to 5, so x is equal to plus or minus the square root of 5. Is no? It has to be positive. Yeah, it would have to be positive of root 5, which if you took the square root of 5, it's like 2 points something. So C is like 2 points. Yeah, good times. Okay. Do you want to confirm it by a calculator? No, we're good. Let's go. Okay. The equation of the tangent line of the graph 2x plus sine x plus 1 on 0 to pi at the point where the solution is the main value theorem. Awesome. All right. Derivative? Ooh, sorry. Hello? 2 plus... Oh, you guys are awesome. Yeah. Okay. So if you plug in, if you use the mean value theorem, so you go f of pi minus f of 0 over pi minus 1, and set that equal to the derivative, so 2 plus cosine x. It's not pi minus 1, it should be pi minus 0. I'm sorry. Thank you. You know what? It's a circus. It's a circus. Alright. So this would be 2 pi minus 1 minus 1. Plus 1, sorry. 2 pi plus 1 minus 1 over pi is equal to 2 plus cosine x. I think the pi cancels out. I think it's just 2, right? Yeah. So 2 is equal to 2 plus cosine of x. 0. So x is that between 0 and pi, though? Which one between 0 and pi? The first one. So we're going to go with this, right? And then plug it in. So f of pi over 2 is equal to 2 times pi over 2 plus sine of pi over 2, is it minus 1? Plus 1. 2 is gone, so that's pi. Sine of pi over 2 is 1, right? Is 2. Yep. So if you were to, so that's the y, that's the x. So your slope was 2. So if you were to rewrite this in linear form, right, that's y. Sorry about that. Using the point slope formula, right, you would go y minus y1, so y minus pi plus 2 is equal to m, which was 2, times x minus x1, so x minus pi over 2, right? That's your x, that's your y, and this is your slope. Sorry about that. 2 was your slope. Yay? Yay. Okay. Oh boy. Here we go. Yeah. So if you were to work that all out, it would just be y is equal to 2x plus, is it 2? Yeah. Joy. Yay? Sure. Okay. Last one. X to the 2/3. Yeah. Yeah. If x equals 0, then it's not. So x equals, it's not differentiable at x equals 0. That's it. That's it. Not differentiable at x. Time. Yay? Okay. wants. I would highly suggest finishing up that classwork before you leave today, so that way you have this whole entire snow day to work on your IAs, right? And your paper 1, which everybody got paper 1, correct? Yay? Okay, so get that worksheet done, turn it in, and then you got the rest of the time to work on whatever you need to work on. Here you go, my love. Yeah, that's 1. Excellent.